So at any point, if you guys have any questions, feel free to ask. And I've not really done a good job at all with the presentation, so I'm flipping in between code and whatnot. So let me see if I can hide this actually. So yeah, most of this, I mean, I'm just talking about Jetpack Compose. This is an example of a composable function that builds a view. I think most of you, or some of you might know this. I don't know how many of you have worked with these concepts. So like, I don't know, I'll try to talk at whatever level works. So you annotate a function as a composable, and you kind of build a view within it. And composable functions, once they're marked as composable, they're a little, special to some means. You only can call them from another composable function. They're not like they're rudimentary functions and whatnot. But this does add a little bit of like complexity to this, right? Like these are not SwiftUI structures that you can know when they're created, or rather have like a lifetime and stuff. These are functions that kind of execute like normal functions do. So it's a little different that it works like that, and that brings like a level of complication when you're building UI kind of like this, instead of using maybe what everybody knows to use, like classes and those kind of concepts and stuff. So when you start doing something a little more than just creating a view and adding something called like state or whatever, things get to be a little more complex than just the normal. So Jetpack Compose does provide us with something called a state interface, and it provides us with helper functions. Mutable state is one of those functions that gives us a reference, like basically helps us in maintaining state for composable. So just getting a little deeper over here, pretty much. A mutable state, as I mentioned, returns a state type object of whatever value you provided in its constructor. And so I have two different states going on here, 4 in total, but I guess they're coupled as 2 different outer and inner ones. And so the concept I was trying to touch over here is the fact that like your function executes and it's done executing like any other function does. So for example, if I had a function named like, print x, and it doesn't take any parameter and it just references a variable x outside of the function, then it would just print that value. And it's kind of what it's doing over here, right? Like I'm just using a either variable that's inside, that's called inner, or a value that's outside, that's called outer. And kind of like you would expect in a function, if I had an inner variable that was called y and I named it 0, the value of y just stays in that function. X can keep on updating. And if I print x from the function, the next time it updates that new value. And that's kind of what goes on in this function as well. I have a button that uses an outer and an inner value, and it's just kind of showing that your state outside is going to maintain longer than the function will, at least the scope of the function. Maybe I can instead share the code in this matter. Okay, so just checking again, this is the screen you guys are seeing, right? The code screen at this point. I hope so. That would be nice, I guess. So this is the same function, I guess. I was using the outer and the inner value. Obviously, yeah, so what I will do is just run this really quickly to show you what it looks like as an example case. Move this to the side. So all this does is I have a button and it uses those variables. I'm just changing the text and the number counter over here to just kind of demonstrate what's going on. And so when I click it, obviously it's incrementing the value of the outer state. And the reason for that obviously is because when the state is recomposed or rebuilt, kind of it regenerates these two values, the inner ones, which are not going to stay. They're not going to be saved because it's regenerating it because it's a new function being called for this composable. As I mentioned, because the state of outer is outside the scope, and in this case, kind of like a everlasting situation. It's not gonna. It's just gonna be created once and kind of live there. It can survive that each time, or it'll just update it and keep updating it as much as you want. So obviously, how do we go about, not having global states around Jetpack Compose? You don't want to have global sized variables and whatnot, or globally, even like, basically something that lives outside the function. How do you want to have it be maintained and whatnot? So that's where the remember block comes into place over here, provided by Compose. And essentially what it does is it lets the state live beyond the recomposition time. And so anything that would have been destroyed and recomposed, it lets basically essentially caches that value and then when you recompose it, it pulls that last value that was over there. So in a way, it's kind of thinking about like, because this is being recalled again, the function's being called again, how do I have this function hold a reference to a value to something that is longer than the function scope itself? And you could think that remember kind of does that out of the box. So it's pretty handy. This is essentially then performs what the same thing does up here, but from within just the mutable, from this composable, which is the meetup2 fix itself. And I can kind of just do that by running the next one in line. And it'll pretty much behave the same way. It's just showing that your remember holds the value for longer scope than the inner one does. And it does essentially the same thing in this case, without having to have a value at the global scale and whatnot. And then touching on the mutable state part, this essentially is like the state system for Compose, kind of like the state stuff that exists for Flutter and the state annotation for SwiftUI. If you bind it to something in your code, in this case, I have the counter and like the text that's using the state, it kind of recomposes those composables as well with the new value. And that's kind of, it auto binds it to some extent, so you don't have to worry about, if you're using like RX or something, you don't have to worry about composite, like subscribing and disposing all those things. It just does it automatically. And so mutable state exposes a variable that you can update. If you also just have you have different state types. I think I talk about it in a bit. So yeah, because I'm changing the values of these, like the text and the counter, it's a mutable reference. I just want to continue changing those. So for that, chat about remember. Okay, so touching on maybe the next thing, and I kind of ran into this, that's how I learned about it, but let me talk about lists, because I essentially thought originally that you could just have a list and assume that if you have a list, and because the list state changes, maybe the whole list is rebuilt, but that is not what happens. It doesn't automatically recompose the whole state, and that's why they have provided helper functions for state or lists and maps. And one of them is mutable state list, where you essentially do kind of the same thing as a mutable list in Kotlin, and you can keep on adding or removing values. It exposes the same functions that a mutable list would, and lets you use them around. So let me run this one. That kind of shows what's going on here. Whoa. And then I'm hiding my run button. Okay. And so this essentially does the same thing. It just lets me add things to the list, because now I have a mutable state list of, instead of just a state that's holding a list reference. You can also do map the same way. If you had like a map that you were, reacting to for some reason, you can do the same thing with mutable map of, or mutable state map of. So I was just giving an example of state list. I think one thing that I did want to touch here that I guess I did differently between the two, and it segues to the next topic, was essentially each time I'm clicking the button in both of them, I add a new value to the list, which is just a random number with a specific seed. The difference between the two is that in the first case, it's not doing anything, but I essentially regenerate the number each time, or the seed each time. Or from zero, basically. It's not like holding reference to it. So every time you'd click this and it would generate a new number, it'd be the same number, because your random generates the same sequence of bits with the same seed each time. But it also starts from zero in this case, and it would always start from zero every time you clicked it, because it's generating a new object of random. Whereas here, and that goes to my next topic, I remember the state of random. In this case, it's 9. But I'm at least holding reference to it, so that the next time I call the next integer for random, it uses the one that exists beyond the scope of the function, and then generates the next bit for it. That's why I get like a bunch of random numbers out of this. It will generate the same sequence of numbers if I return 9 again from the seed, but that's just how the random works. But derived state essentially provides kind of, you can say, a immutable state. And then what got confusing for me in the starting was like, why the hell would you want to have immutable state and not just, like use it, pass it as a value or something? What's the purpose of a derived state at that point? But essentially how derived state works is that if this was reacting to like some other value, and I don't have a good example for this, but I tested this out with like just XYZs and stuff. If derived state is referencing a mutable state, for example, then essentially it like lazily evaluates it to some extent. Like it'll execute that number or execute the lambda and then cache that, right? Like cache it beyond the scope of this function. The next time somebody asks for it, if the value is the same, then it uses that again. It doesn't recalculate the lambda. It uses the same one. And the next time, again, somebody asks for it, if it's the same value, then it just uses that one. But if the next time or something else changes the value of whatever is being calculated here, then it lets all the composables that was reacting to it know that it changed. So it kind of acts the same way then that the mutable state did. Everything gets recomposed automatically. So it's a good, like a mix between there. Like if you have something that's, typically if you're like calculating something that's going to probably stay the same for a while. And I think in the composable documentation, they're talking about like, if you're doing something in like coroutine scopes and you're having miniature calculated functions, then you might as well like cache them like this. And then at some point, if they change, like if the state of data changes and stuff, then automatically things that are reacting to this state get recomposed. And then because it's a variable or it's immutable, it doesn't allow you to change the state inside of this. It's a good way to force some structure to that area of your code as well. Like at least this is not a mutable state. So in this scope, maybe you're just allowing a read-only value pretty much. It's pretty handy, but again, I guess it comes useful in certain cases. I'll have to like come up with a better example maybe next time. So that's derived state. And then I guess I'm going to touch on launch effect really quickly here, and maybe the next one after that. Okay, there's only one, I guess. Okay, so let me run this one really quickly. Essentially, essentially what I just wanted to mention here was like you can, if you want to run coroutines from within your composables, you also don't want to have them run each time the function is recomposed, or you wouldn't know like if something recomposes this function either outside of it or inside of it. I guess maybe rather inside of it. Your coroutine would maybe execute without you knowing when. If it didn't if you just did a random scope.launch or something. So that's why compose gives you some handy functions as well. Launch effect gives you a parameter or a couple parameters. Actually, it gives you like I don't think it's a var arc, but they give you up to like 3 parameters, I think, of different keys. And if their state changes, then your scope inside basically can re-execute. So it doesn't re-execute the coroutine inside unless the state changes pretty much. So it's pretty nice because then if you are essentially listening to like the state change for something like a bottom sheet or a navigation drawer, then you have like the benefit that the drawer or the sheet has the last state as well. So you can hook onto that. But then also like you're not like you know when that coroutine is going to be executed because you're remembering that state now. So like for a fact that you're binding to the state of the drawer, so this coroutine will execute only when the drawer is opened or closed or whatever. So it's super handy, and you can launch like whatever other coroutine stuff you want to do in here. So it's pretty nice in that way. You have like expected execution points over here, and it gets canceled as well once this is once like meetup effect is not in the composable like cache anymore if it's destroyed and stuff. So if something was like ongoing and whatnot, it just gets canceled. And that maybe the last thing that I touched on was just something called snapshot flow, which you can technically use outside of like coroutine scope. It's not inside of that. It's just because I'm using collect, which is a coroutine kind of thing. I'll probably just do collect as state here and it'll work. But essentially what snapshot flow does is like, and I'll probably like link the resource after this, but because there's like a snapshot system in Compose, it's like a inbuilt reactive system, and like composables are observers. You can essentially convert your state, your mutable states or your derived states or whatever states into flowables for coroutines, and that's what's going on here. And so essentially like, I have a counter for that button again. All I'm doing in this coroutine because I'm launching it as a flow, is I'm just like mapping it to a string and then printing that in the logs, which I actually do down here. I should have probably showed that earlier. Whoa. Those are okay. I guess that showed up. Whatever. Yeah. So it's just logging it each time I click. And essentially the use of this is that like you're able to, if you wanted to map values or do some other logic, filter something out, combine a couple of them together, or combine a couple of states together, because they're reactive streams to some extent, you can convert them to flows and they just work with those as well. You're not like stuck to, I don't know, you're not stuck to doing logic in like some other file or whatever. It's really easy to just collect different state flows and kind of work with them and whatnot. So that's essentially what snapshot flow does. That's also part of the API, the compose API. So yeah, launched effect for coroutines, snapshot flow converts their states into flows, and you can kind of use them however you want. You can combine a couple of them if you want. And then as I kind of showed there for a second, you can, once you have a flow, you have the added accessibility to just collect a flow as state and provide an initial value. And then this is awesome because then if you use the state in your text or your screen, whatever, however your model is, that it just recomposes itself automatically. So it's very, very handy. I mean, I've used this in a couple of side projects. It's insanely easier to do this way as compared to like some of the stuff we've done in the past and whatnot. So it's pretty sweet for what it is. Now snapshot flow. And yeah, that's pretty much it. I didn't want to go into collect XYZ as state. That was getting a little too much overkill, to be honest. So I'm just going to end it there and pretty much open it up for questions if anybody wants me to like re-explain a particular point or whatever. I might have
that last chunk of logic. I do not understand the collective state. What's that solving you in terms of, I guess, what are you leveraging it for in a real life example?
Collect a state. Like if I was doing like, so I've used this in like, were you in the screen? Okay, like there's like a, what is it called? Server UI talk that I did maybe a couple months ago. So like I'm fetching like the screen from the API.
Okay, so I wasn't there. I haven't been here for a while, so.
Yeah, it's kind of sad, honestly. But I was fetching the screen from the API, and then I just wanted this layout to update from that screen. Screen mean like just imagine the whole screen's like layout as a JSON.
Sure.
So as soon as that composable is like provided, right? Like as soon as I launch the composable, I fetch the screen, and then I just collect it as a state, and then build a screen based on that state.
Yeah, but what's like? I guess I've just been getting introduced to compose, so I would expect. Why couldn't you do the same thing as like when you build a composable and you have your generic states anyways? What's stopping you? I guess I don't understand the leverage here.
You can I could totally have the networking layer return a state type and then just pass that down as well. That's totally possible. If I wanted to do any like, if my mutable state in this case, like I was having an increment counter, right?
Okay.
So like, I mean, I feel like I'm mixing two different like examples here, right? Like there's the example of if I have a state that's just an integer and I'm just like incrementing it by 1, and then I have a text field that updates it. But let's say I want the text field to, I don't know, map that value like you would for RX, right? Did you ever use like RX Java and stuff, right? Then you can use that flow stuff from coroutines and do it, right? And so if you use the flows from coroutines and do it, but you want that to, again, be reactive from somewhere in Jetpack Compose, then you collect it as a state and then bind it to something. Does that make sense?
No. I would love to see your real life example. That's the best way for me to look at it. But like we've been trying to build out some composables for an SDK we're building out. We've kind of halted on it because we are missing some very core fundamental understandings around it.
So are you asking like what's the purpose of collect as state?
Yeah, I'm probably missing some more fundamental understanding of, because I just assume you have a composable, you can like subscribe to coroutines. I mean, you can subscribe to the live data, and I've seen those examples a ton of times, and you can respond to those live data getting updated, and that would recompose the UI, right?
Okay, yeah.
So if you were to share your screen again,
the same.
You show that again? Yeah, that same example.
Why can't I share a screen with Zoom? Okay, I can share the ID, I guess. Okay. So this part, right, is what you're saying. Ignoring
So
the
that,
fact. Okay, there, right. Just ignore the fact. Okay, yeah. So this is this, right?
yeah, I mean, the launched effect is its own thing too, because I've seen that used. You're essentially just launching a coroutine whenever that property is getting updated.
Yeah,
Inner
or
counter.
like put it in another way as well. Like it manages like launching the scope and then like canceling it appropriately as well. Like it won't like relaunch a bunch of times. If this composable changes or whatever and whatnot, this function re-executes, right? It's
Okay.
based on like this state in this case. That's what
So
launch does. Yeah.
you'd have the ability to just spin up any coroutines as soon as that property is updated in the state. Okay. So
Yeah.
then why would you pull out snapshot flow outside of the coroutine and then collect it as state? That's what.
I don't think I have a good example in this case, right? In this case, I think I was saying something like, I think I could do something like this. Instead, and then have, because this is gonna collect as a state.
Oh,
I
okay.
down there to use it, yeah. But then it gives me the added benefit that I can do like whatever I want to with.
Right. All right. So then you're now given just another state that the whole composable reacts to.
Probably not. No, yeah. So this would be like, again, I don't think this is like questionable on like why would you be doing this much logic at this level of composable for sure. But it does let you like, mutate. It's like a combination, right? The flow lets you, combine and do like those weird higher functions on coroutines and then collect them as is. I think collect as state is more for like compatibility purposes than actually like you using it if you're building something from scratch. Because if you've built it out of like coroutine, if your code is already using coroutines for the most part, then you don't have to worry about having any compatibility layers and stuff. But that's essentially
okay. Launched effect makes a lot more sense now.
Yeah. Their examples again, like their examples in documentation I don't have the good examples either, but even their examples were like they're making an API call when like a drawer opens or something as well. So or service or something. So it was like questionable on like, you can do this and this is how you do it. Questionable once you start architecting it like properly. Why would you do it in here and not like, either hoist it or like do something outside? But essentially, like I 100% agree with that. This is more like it's possible. This is how you do those.
Mm-hmm.
So that and launched effect key one equals inner counter. That means if you had something else that was triggering a redraw, that launched effect doesn't fire again as long as interconnect counter didn't change.
Yeah. Unless like the whole thing gets destroyed for some reason, right? If this was inside of a screen and that screen got destroyed, and then a new screen got over, and then this screen got launched again somehow, then it would kind of do this whole logic again. But essentially at this level, you're right. Like if inner counter doesn't change, because I did this with like the text field accidentally once, and that's where I bugged out, and I was like, why isn't this getting called? So if I did this with text instead, the inner text, then it only gets called once, and then it never, I believe, recalls.
So it creates a local state to the view versus a long-lasting state. Okay.
Similar to like what remember does, but then launched effect is primarily for the life cycle of the coroutine, the scope in there. So coroutines, if you've heard, I guess, like they're asynchronous stuff, right? So
so like if you're opening, like you were talking about, like you open a drawer, maybe that drawer has some sort of data capture it needs to do, and so you go do that capture one time, and then you don't need to do it every time the drawer opens.
Correct. And again, like as I was just saying, like the cool semantics, cool stuff. I don't know why you would be doing those things at this level, maybe for edge cases and stuff, and maybe you will have to do those at some point. But for like the most part, even their examples that I was seeing, I don't think I think maybe launched effect you'd use it, but for the most part, these state changes and stuff, you wouldn't want to like have it done at this level. You'd want to just like have something outside of this scope manage kind of those things and whatnot. Generally.
Right, because you would expect like a callback. If you open up a drawer, you're going to say view model dot go fetch that data, and then you'd update the state accordingly.
Exactly. Yeah. And I mean, like for the examples that I've seen, unless you want to show me code, like you can use mutable state. I guess I probably didn't show that. I mean, you can use mutable state outside of this, of course. Like you can replace your existing, like your flow system or your RX system with mutable states, and use that if your views are or your data is binding to your view eventually. Anyways, it doesn't require composables at that level. It just requires like mutable state to an extent, right? But then to react to those changes, you do need to execute them and then composables and whatnot. There are people who've made like I don't want to go so deep into that side of it, but like I'll post a link. But there are people who've made like their implementations of like snapshot observers, which is what composable uses to listen to changes to mutable state, which is like making your own like reactive system to some extent. That's possible, but that would be like, I feel like that's like an overkill to some extent. But yeah.
So if you open up your, sorry, you keep stopping your share, and then I immediately want you to share again. If you go back to your derived state, because you were talking about like the inner part, not quite having a use case for it. That random seed 9, if that random seed 9 was actually like random seed based off of UTC now, would that mean that your derived state would constantly be regenerating because your random is constantly being regenerated? I guess, does that make sense? Because like your now is always returning a new value. So random is always different.
Correct. I think I'll have to think about that. I might be messing those two up again then.
Or is it more like a one and done? Like whatever UTC now is, we derived that state and now we remember it for as long as the view is present.
I have to try that out now that you mentioned that, because I feel like it would. I don't even know how I'd find that out, honestly. That's a good question though. Part of me thinks that it would do the same behavior because it's not hooked to a state change, and I don't know how the system would know if that state changed under the hood. Like it would be weird if it was recalculating it and then checking it and then updating the rest of the views, right? Like unless like UTC was hooked to a state above this line and then I used that state over here, maybe it would change. But if I did like UTC now here, I feel like it would just do it once. I'd have to try that out. That's what I think. The example that I tried it in, I was hooking this to a name over here that was a string, and I was changing this string, and based on that I was seeing if it was getting, if things like that this was observing was changing or not. But that's again because like this was referencing another state. And that's what like the documentation said of it. So it's a good question though, but maybe, yeah, I would try that out. I think it would change if you're using a different state, basically.
You could probably just, I don't know if you can just drop UTC now in there, but you could also drop a print statement in that derived state of, I'm assuming.
The thing is, I don't think it would work like that actually. Okay, is that how you do it, by the way? Is it UTC now or?
I'm sorry, I am not familiar with Holland.
I don't even know what the time APIs. Any Android guy who knows the time APIs, not using the 310 library, what would it be?
Date.now or date. You have to initialize it, I think. So.
I was gonna say calendar.now.
Or yeah, I never remember.
Millies, or I don't know.
Oh wait.
Oh no, hold on. Oh, calendar.getinstance.now. That works too.
You guys, come on. I'm kind of disappointed, honestly.
That's why I look at the documentation. I don't remember it all.
I actually don't know how I would show this is working or not, to be honest.
Can you drop arbitrary code in there? Could you just do a print in the derived state of? As long as you return at the end.
Like printing the actual current time.
Oh crap, did I just forget? called it only once, I guess, technically.
And then if you, I guess this is part of a column, so you need to add, or are you doing it off screen? The multiple ads are still generating.
Yeah, I don't have the scrollable. Oh wait, it is. Damn, nice. Wait, I'm wondering if how did I just think it would do this? Because I'm not sure if this would get re-executed, actually, part of this. That's why I'm kind of doubting, even if this was getting recalled.
Maybe that's a Kotlin question I'm unfamiliar with, but why would you not print if you're generating a new random in your closure?
That's a good question. What do you mean, like how I've done it, or?
No, I was just thinking more language basics. If that's a closure that is executing
yeah.
and returning a value,
No,
to execute, it would have
Yeah.
to print again.
Fair enough. Fair enough.
Isn't it just because that remember block?
I think so.
I mean, the current
Then-
time is like captured in that initial invoke, and then it never changes.
Oh, you guys can't see the emulator, sorry. Or the phone.
Yeah. So I assume you're getting a new list of randoms
Yeah.
each time. Hey, we can see everything now.
Sorry. So, oh my God, this is like so hard with the one monitor. Okay. So that's what I was doing. Sorry if you couldn't see that earlier.
Okay. So we executed once. We have -98, -15, -7. If you run again, you probably will get not -98 and not 15.
Probably not if it's using that time. So that, and then like the high is only once. That's what I'm wondering is like, how would I do this to change it though, each time, or redo it each time? I don't know if I would actually if it was under remember, so never mind.
Yeah, it seems like this is your read-only.
It's true.
Read-only value that you want to persist between redraws, like only do once.
Yeah.
So as I'm computing it in my head, that's kind of like we have a state value in Swift UI, you might be nesting another view inside. And so your view, outer view might have some sort of state that you're passing in here. But you need to hold on to that.
Correct. That's what the remember does. I'm actually wondering how I would not have this with the time at least. Am I like doing an overkill? I was like thinking if I had a callback that just updated every second on a different state and then have the derived state use that. That would probably show that this could change, and then the things using this that are reacting to it could change as well. Like then it would kind of like show an example on how you could re-execute that function and not lazily evaluate it just once, right? That's what I meant to say. Like how would I break it basically? I might have to write a better example for that.
I could also be asking a nonsensical question, not being Android.
Oh, I mean, like it makes sense though. That's kind of what I was trying to show. Is like it would be dumb if it tried evaluating it and then checked it if it was the same, right? That was like the point of it. So it would have to know, like it would have to react to like the some system or something to know that it's changed or not. I guess.
Cool.
Yeah.
I'd say that was a lot more polished than I was expecting for someone who didn't have a presentation.
It's not. I wasn't sure about giving this at all. But I wasn't sure on like the good examples as well. That's why I had a couple different ones, and I went with these just as a basic matter. And I ran into those same issues of like these exist, but I don't know why you would do these, and like the composable layer and stuff for the most part. It seems like, as I said, like they made it for compatibility purposes for the most part, but yeah. But yeah, if you guys are interested in getting like a much better, I mean, I have it on my computer actually. I don't have it here, that's why I'll have to post them later. But there's a person who's done like a 5 blog kind of in-depth look into like the state system. And then they talk more better about like how Compose is able to like automatically update values, the snapshot system, how you can kind of build your own one and stuff along those lines. And I'll post that maybe in the Slack channel after this for my computer. That was really good. That's where I got most of my info from. That person did a really good job, honestly. I did not. So anyways, let me stop. I shouldn't have put that on the video.